Today I am going to find out the complexity of quicksort algorithm. So quicksort is nothing but a divide and conquer approach where we divide the problem to two sub-problems and we combine the solutions. So the problem is we have to sort an array of size A with indices P2 R, and in the divide method partition the array A into two sub-array A with indices P2 Q and another sub-array with indices Q plus 1 to R. So actually we are dividing the given array A into two sub-array with size P2 Q and from Q plus 1 to R, such that each elements of A P2 Q is smaller than or equal to each elements in A Q plus 1 R, and needs to find index Q to partition the array. So we have to find out the Q's such that all the elements in A P2 Q are smaller than the elements in the array from Q plus 1 to R. So in the conquer phase we have to recursively sort A PQ and AQ plus 1 R using quicksort, and we have to combine that is the trivial, the array are sorted in place, no additional work is required to combine them, the entire array is now sorted. So the combine method is not same as the merge sort. Here it is already sorted. Now this is the algorithm for quicksort. So here we have to check the base case, then we will partition the array into two sub-array. Actually we have to find out the position Q by partitioning A with respect to P and R. Then we have to call quicksort algorithm for the array A with indices P to Q and quicksort for the array A with indices Q plus 1 to R. And the recurrence for quicksort is nothing is Tn is equal to Tq plus Tn minus Q and F plus Fn, where Fn depends on the partition. Okay, so Tq is the time to solve the left sub-array, Tn minus Q is the time to solve the right sub-array, and Fn is the complexity of partition. So partitioning the array is nothing but you have to choose the partition. There are different ways to do this. Each has its own advantage and disadvantage. Select a pivot element X around which the partition and grows two regions API, that will be less than is equal to X, and X should be less than is equal to AJR. Okay, so here J is nothing but Q plus 1 and I is nothing but Q. So this is partitioning the array algorithm. So AP is the, here we are choosing the partitioning element at the is the leftmost element, and I is P minus 1 and J is R plus 1, and we are repeating the process to get the solution. So this is the recurrence of quicksort. So we will focus on the recurrence Tn is equal to Tq plus Tn minus Q plus N. Okay, so the depending on the selection of the partition position, the complexity will vary for quicksort. Now for worst case partitioning, the one region has one element and the other has n minus 1 elements. That means if there are n number of elements in the given array, now in the there will be only one element in the one region and there will be n minus 1 number of elements in the remaining region, and this is unbalanced, maximally unbalanced. So Q is equal to 1, so the recurrence will be Tn is equal to T1 plus Tn minus 1 plus N, and where T1 is nothing but theta of 1, because if there are only one elements, the complexity of quicksort will be theta of 1. So we can write the recurrence Tn will be Tn minus 1 plus 1. Now this is the n, this will be n plus summation over k from 1 to n, k minus 1. So it will be theta of n plus theta of n square, and that is same as the theta of n square. That means there are n, the height of the tree will be n, and so actually we have to sum up from 2 to n, and that will be theta of n square. Now when does the worst case happens? When the list is already sorted and we are choosing the pivot element as the leftmost element of each partition, then we will get the worst case time complexity of quicksort as theta of n square. Now best case partitioning. So best case partitioning is nothing but we divide into two region, and the recurrence will be 2tn by 2 plus theta n, and if we solve it with the help of master theorem, we will get that will be theta of n log n. So this is the best case partition. Now the case between worst and best case, that is we will partition 9 to 1 proportional split, and the recurrence will be qn will be q9n divided by 10 and qn by 10 plus n, and this is the recurrence tree. The height of the recurrence tree will be log n base 10, and another will be log n base 10 by 9. So using the recurrence tree, if we solve it, then the longest path will be qn, that will be less than is equal to n summation 1 to 0 log n base 10 by 9 1, that will be c2 n log n, where c2 is the constant, and shortest path will be c1 n log n in the same way, and thus qn is theta of n log n. So time complexity of quicksort is nothing but theta of n log n.